that D is equal to -2. Okay? And so how do I know how to do all of this, by the way? Any thoughts as you guys look at this? Well, what I'm literally doing, I'm just setting like terms equal to like terms. Okay? So 16 comes from the fact that we have the term above that you can see that turns into 16 as a result of that. Okay. If you have any questions about this, please let me know. I'll be happy to answer that. And then with s equaling 9, we have 248 set equal to 648 times c. And so this will imply that c equals 31 over 81 when you solve that. And then last, we have s equals 2. So this will be 45 when we solve this correctly, equals -14 times a. Okay? And what you can tell is if you plug in 2 right up here, right, you get 2 minus 9 is -7 times 2 is -14. So I'm just showing you guys where this all takes place. So s equals -2, we get 45 equals -14a plus 4345 all divided by 81. So this implies that a is equal to 50 divided by 81. What this reminds me of, and what you should be thinking of, is when we did the method of undetermined coefficients, we did pretty much exactly the same method. It uses the same process to solve for these different unknown coefficients. Okay, so plugging in all those values, we end up with the following Laplace transform solution. We get 50 over 81, okay, divided by s, all right, plus 5/9 divided by s squared, okay, plus 31 over 81, all divided by s minus 9, minus 2 divided by s minus 1, okay? And if you were to do back transformations to get to the right answer, this is what you would end up having. Notice this is 1 over s, right? This is 1 over s squared. This is 1 over s minus 9. This is 1 over s minus 1. And then you just pull out the constants, right? So to do a back transformation, it's actually very easy to do the inverse transformation because you guys know what 1 over s is, right? That's just 1. And so that's just going to be 50 over 81 times 1. That's what f of t corresponds to. Laplace transformation of 1 over s is just 1. What about the Laplace transformation of 1 over s squared? You guys know what that is. That's t when you look at the table. So that's just going to be 5 over 9 times t. Okay? What about s minus 9? What do we do with that? Well, 1 over s minus anything is actually the exponential, which we saw before. So we just take the constant, pull it out. It's 31 over 81 multiplied by e to the 9t, right? That's a. A is 9. And then the last one, once again, we have 1 over s minus a, which is e again. So we subtract and we have 2. And so in this case, a is 1, so this is e to the t. And there you go. This is actually the final solution, including the IVP. So if you guys are really good at partial fraction decomposition, and you're really good at using the transform table, I promise you, you could literally solve almost every single differential equation out there. And that's very exciting stuff. And that's why we include it in our linear equations courses with differential equations, because then this gives us an enormous ability and a wide range of power to solve just about any system we can think of. All right, well then that's it for us for today, guys. I am so glad you guys had a great Easter break. Looking forward to the rest of the week ahead of us and the next week after that as well. And of course, if you have any questions whatsoever about the material covered here or any of the homework that's being assigned, please let me know, and I'd be glad to provide you nice in-depth walkthroughs of each step as we go. Okay? All right. Be sure to let me know if you have any questions, and you guys have a great day. See you Thursday.